Okay, well, I want to thank the organizers and Fetzer Franklin Fund for this remarkable conference. I don't know about you, I'm starting to feel a little bit giddy after my brain is full. I hope my talk will be interesting. It will give a kind of philosophical presentation. It will be a little bit less about the title than I originally thought, but that's the way it went. But it will present a kind of philosophical picture inspired, possibly inspired by some of Bohm's thinking. This one is probably the slide. Okay, so let's begin. What is metaphysics? And there's a famous quote from philosopher Wilfrid Sellars. Metaphysics is the attempt to understand how things in the broadest possible sense of the term hang together in the broadest possible sense of that term. And what is distinctive about metaphysics, I think, is the fact that it transcends the empirical. So metaphysical questions are ones that go beyond issues that can be directly, at least, decided by empirical means. And that means, it seems, that the interpretations of quantum mechanics are, or at least the pure ones, by pure I will mean interpretations that make no new predictions, though the pure interpretations would appear to be a metaphysical dispute. They would be non-empirical, but that would not mean that there would be nothing to say in favor of one over the other. There might be compelling rational reasons to go for one rather than the other. And as a philosophical aside, they also provide beautiful examples of empirically equivalent but distinct theories. They certainly have different, what Maudlin was calling commentaries with them. And some of them seem to have different ontological commitments, even if those have no empirical consequences. So here's some sample metaphysical questions. And the first one is the most famous of all. Why is there something rather than nothing? Why does anything exist? Another, why do things, in the broadest possible sense, obey the laws of nature? Whatever answer you give, the laws of nature will remain, the empirical results will remain. It's an interesting question. You might think the laws of nature reflect the causal powers of the entities, but of course quantum mechanics makes it seem that that is not actually the correct way to understand the laws. Another, do abstract entities like numbers exist? Is the world one or many? And my favorite, why is there consciousness in the world? Subjective feeling. How does matter generate consciousness? Now, it's natural here to talk about the relation between metaphysics and science. It's a long and fraught relationship. You can decide which is which in the picture. And your answer might be different than it would have been 300 years ago. But it's sometimes a difficult relation. And there is, of course, a branch of philosophy itself, and lots of people outside of philosophy, who will say metaphysics is bunk. Famously, the positivists said it was bunk, and they said it was bunk because it transcended the empirical. But positivism has not fared as well as metaphysics over time, and its thesis itself transcends the empirical. Well, we have modern neo-positivists, and here's a nice quote. Any new metaphysical claim to be taken seriously should be motivated by and only by the service it would perform in showing how specific scientific hypotheses, at least one of which is drawn from fundamental physics, explain more than what is explained by the hypotheses taken separately. So that's a very strong thesis with little to recommend it. But it is fairly stark. I know why they limit to metaphysical claims. Why is just any claim? That would be super scientism, I guess. This is mere scientism. It seems to me obvious that the sample questions I was giving are obviously meaningful, significant, interesting, and intellectually approachable. And that would be true even if some of them are actually unanswerable. But the relation between metaphysics and science is not generally a difficult one. It's traditionally been rather friendly and supportive. Right? Sorry, let me get back. One more difficult relation. I have to give you this just because it's so funny. So it's not always been friendly. And take the question, why is there something rather than nothing, which I picked because there's a recent book by Lawrence Krauss. There's the book with that very question in the subtitle. And this occasioned the New York Times review by David Elbert. I encourage you to read the whole review, more than the book actually. But here is what Elbert says. Here are the two contestants. Elbert says, what on earth can Krauss have been thinking? His book has nothing whatever to say on why there should have been a world in the first place, period, case closed, end of story. To which Krauss replied incisively, a moronic philosopher did a review of my book. Okay, anyway, although that's amusing, and sometimes it's like that, but actually the relation between science and metaphysics has been very fruitful and generally friendly and often deep. If you think about the scientific revolution or the first scientific revolution, the resulting metaphysical thesis, the mechanical worldview, drew upon that science and acted back on the science. It was extremely fruitful. I think it would be hard to overstate the transformation from religion and Aristotle to science as metaphysical inspiration for metaphysical thinking. Maybe we're going through another such watershed moment with the inspiration that quantum mechanics provides. So we have so-called experimental metaphysics. Now, the first scientific revolution suggested what could be written down as a very austere metaphysical view of the world, which is called pure mechanism. This is developed by C.E. Broad. No one ever held pure mechanism, but it is kind of the perfect expression of a certain kind of view. One kind of stuff, one kind of change, one elementary causal law, and a single principle of aggregation. Right? And everything follows by aggregation from these bits, right? The constituents taken by pairs, Broad says. So you can see the picture, right? It's like billiard ball picture, except the billiard balls are very small. This I call the parts project. And after the 17th century, science was charged with completing the common sense vision that the material world has a part-whole structure. It's obvious things have parts, and it's obvious that the way things act depends on the parts. So let's carry that as far as we can. And if you succeed, you'll end up in something close to pure mechanism. Pure mechanism had kind of little problems here and there. Forces had to be introduced of various kinds. Fields had to be added. But they had sources, which were these little material bits, so that was still okay. There were attempts to produce mechanical models. I think it would not be too much of an exaggeration to say that this project has been the most successful intellectual endeavor that human beings have undertaken. And if you look around, our technology is completely based on putting together little tiny things into amazing devices, right? Well, they're all over, right? I think my phone has 17 billion parts, right? The transistors inside the chip, something like that. And it still freezes from time to time. However, the parts project collapsed. Right? The great irony, right? Quantum mechanics really seems to explode the parts project or reveal its limitations, right? So here's some quotes from eminent physicists, one of whom in the room. Schrödinger said, a particle certainly is not a durable little thing with individuality. The mechanical worldview thought, okay, the little parts are individual entities which you could track. You could put little labels on them in principle. That does not seem to be the case. The quantum chemist, Hans Primus, says the idea that the material world is structured by some kind of interacting elementary systems is in sharp contradiction with QM. Hiley says quantum phenomena require us to think in a radical new way, a way which we will have to ultimately give up both the notion of particles and fields. And David Bohm, whose 100th birthday we're celebrating, said the entire universe must, on a very accurate level, be regarded as a single indivisible unit in which separate parts appear as idealizations permissible only on a classical level of description. So that's a nice description of holism. It has a very important component that the parts are mere idealizations. Right? The whole is primary. You can see parts, but if you do, it's you sort of doing the abstracting, not the world. Which I guess raises this big question. This is Merman wrote a paper with this title. What is quantum mechanics trying to tell us? Well, I mean, is there a metaphysical inspiration we can draw from quantum mechanics? And every pure interpretation of quantum mechanics is a philosophical answer to this question. Now, there are too many. I'm sure not going to go through the interpretations. Wikipedia begins by listing the 18 common interpretations and then gets into the scholasticism of it. But there are many, many interpretations. But here's one, the Copenhagen interpretation, which roughly it says quantum mechanics is about what we can know about observable reality. Famous quote from Bohr, "There is no quantum world. There's only an abstract quantum physical description. It's wrong to think that the task of physics is to find out how nature is. Physics concerns what we can say about nature." Now, of course, this is for Bohr an absolutely crystal clear statement. Right? But the view is now regarded as philosophically quite radical. And there's a quote from Tim Maudlin here that is the only philosophical use of this technical term I've found. I take it no one pretends anymore to understand this sort of gobbledygook. I'm not so sure that there isn't a viable anti-realist view that one could advance, which would begin with something like the idea that if you wonder what ultimate reality is, open your eyes. This ultimate reality is the world we experience, and then there will be many models of it, which you can use for various purposes, but you should not necessarily give credence to. But anyway, that's the Copenhagen view. It does have a particular metaphysics behind it, but it's, of course, only one of many, many possibilities. By no, not very popular at the moment. Now, Bohm, of course, had views. I want to try to extract a few. How directly related, it's not obvious to me Bohm would have agreed with what I'm going to say and how I use his ideas. Some of them maybe. But I want to present a philosophical picture in which these are used in a way which is a little bit different from what we've been hearing about, which will involve information and mind. Right? So the three views are going to involve holism, information as being a fundamental feature of the world, and the mind as being the basis of the information. So I see a kind of argument that follows this trajectory from holism to information to mind. So let's start with holism. The metaphysical thesis of holism is that the whole, or the totality, is prior to the parts. Right? And a symptom of holism, if you were looking to find some reason in support of a holistic view, well, one might be if you find it is impossible to completely specify the state of the whole by independently specifying the state of the parts. Right? Most of the world does not seem to obey holism in this sense. If you wanted to describe a chessboard, You could completely get it by putting the pieces down where they are, and the pieces can be moved independently. You would have completely specified chessboard, same for a billiard table. But there may be reasons to think that that cannot be extended to govern the entire universe. If it could be, the parts project would have succeeded. Part-whole reductionism will be false in a holistic picture. Again, I think, well, I certainly have strong intuitions in favor of part-whole reductionism, but there may be good reasons to think it is not true of our world. Right? Here again is Bohm's quote. I'll read it again. The entire universe must, on a very accurate level, be regarded as a single indivisible unit in which separate parts appear as idealizations, permissible only on a classical level of description. Now, I think you can think of things that look like holism that I think don't quite count. So there are forms of emergentism that would say that part-whole reductionism is false in a sense. When the parts interact, something new is generated. Right? But that would not be really holism. The parts would then still have an independent existence. Right? If you imagine the world is made of particles that are somehow all talking to each other in some magic way, that would not be holism. Right? You might be able to reproduce quantum statistics with a system like that. It wouldn't drive you to holism. What's important in holism, again, is that the parts should be thought of as derivative. Now, quantum holism, well, the non-separability of some quantum systems has suggested to many people that part-whole reductionism fails. Right? You cannot tell, just by measuring the two particles in an entangled system independently, you can't tell whether they're entangled. You'll have to consider the joint statistics that you get from that. Right? So part-whole reductionism seems to fail. Now, maybe it only fails in these esoteric places, but after all, those places seem to be at the foundation of the world. Right? If we apply quantum mechanics to cosmology, presumably all particles are entangled. Right? There was one creation event. It was some kind of quantum event. We're one big quantum state. Right? It's been, I guess, evolving ever since and remains as entangled as ever. Right? Now, I think it is very strange to me. Maybe this is just me. Why can't we signal in non-relativistic quantum mechanics? Non-relativistic quantum mechanics was not developed with relativity in mind. It's a completely separate theory, and it ends up apparently producing these distant relations between distant objects. Why can't we signal with them? Right? Would it be a problem if we could? No. We already know it's a false theory. Right? Relativistic quantum mechanics is the right theory, the fuller theory, but we can't do it. Right? Now, this might suggest that it's a virtue of holism. Right? Other views invoking communication lack. If you're talking about the particles talking to each other by this magic, well, why don't they really talk to each other? Right? But if we're thinking the parts are mere derivative reflections of some whole, I think the correlations exist. There's no particular reasons those correlations should help us do anything. Right? There's a quote from a quantum textbook which expresses this. Non-relativistic quantum physics is non-local somehow, in a way subtle enough not to contradict the inherently relativistic causality principle. There's another possible suggestion of holism, which is we know that when we take Hilbert space to represent the totality of the system, the state in the state vector in the Hilbert space, well, of course, you're completely free to choose the basis that you want if you want to examine it, right? Now, this also kind of suggests to me, maybe I have to kind of squeeze my eyes a bit, but kind of suggests to me that those parts are derivative, right? They're not the primary thing. The quantum state is somehow primary, and the basis states that you choose to look at, they come into existence maybe, or they're an idealization when you start to that you can choose to look at. You can kind of draw them into existence, but they're, in some sense, aren't there. They're certainly not there making up the vector, right? Now, that's about all I have to say about holism. This is where we drift away from the title, because holism leaves open entirely the question about the nature of this reality, right? Now, if you think about, well, what is the nature? I have a metaphysical picture of the world. What does it say the world is like? The mechanical worldview had a beautiful answer to this question. Reality is material. What is matter? Well, right here. You know what it is. It's ultimately composed of impenetrable, movable, independent, and at most causally interacting chunks, like little Lego bricks. When Feynman once he wrote, you've probably seen the quote, if there was one single idea that I would hope would be preserved if civilization collapsed, it was the atomic hypothesis, which he says is the world is made of little particles that move around in perpetual motion, attracting each other when they're close and repelling when they are squeezed together. But it looks like quantum mechanics is telling us we don't live in Lego world. I think that means we have no positive conception of the nature of matter. None. Right? All we have left is knowledge of how matter, the stuff we call material, structures experience. Now, this structuralist view is quite popular nowadays in the philosophy of science. I think that the structure needs something to make it real. Something to make it concrete. Pure structure is abstract. Right? Modern physics seems to be purely structural. And there are more quotes from eminent philosophers and scientists. Russell says, physics is mathematical not because we know so much about the physical world, but because we know so little. It's only the mathematical properties we can discover. Max Newman, who wrote one of the most brilliant objections to a structuralist view, said, of the external world, we know its structure and nothing more. Eddington writes, physical science consists purely of structural knowledge, so that we know only the structure of the universe, which it describes. So the picture on the side, Rubik's Cube, of course, the description of the structure is above, right? The description is not a Rubik's Cube. You need stuff. You need something to turn the structure into concrete reality. So similarly, if physics is structural, there must be something lurking behind that structure. Well, let's take Bohm's next idea, information and active information. Right? Since structure requires something substantial to transform the abstract to the concrete, maybe active information could play that role. One of the important distinctions Bohm and Hiley make is between active information and what they sometimes call Shannon information, the information that we find in information theory. Information theory is purely structural. Active information looks like it's on the side of the concrete. It's the actual for the subject of it. The analogy is, as structure is to the concrete, Shannon information is to the meaningful content or semantic information. So finally, what is information that isn't purely structural? Well, non-structural semantic information, I think, is paradigmatically mental. It's the content of our thoughts. That's intrinsic, right? Even better, of course, I think it's the content of consciousness. Consciousness presents to us this world. It is what it is. It's not a matter of pure structure. It has structure, but it is also has an intrinsic feature to it. This kind of pure non-structural semantic information is what philosophers call intentionality, and it is a very strange fact that the world is full of these intrinsic representations. So the link between semantic information and the mind suggests the possibility, I say exciting possibility, it excites me, that there's a kind of integration of mind into the fabric of the world, something like this. The mental will become something fundamental, non-structural, and it will be the metaphysical ground of the relations which are explored by physics. Right? This has all sorts of advantages, solves the problem of mental causation. It gives, without saying that physics is incomplete. Physics could be complete, give a complete description of the structure and causal structure of the world. There'd still be a place for this intrinsic, substantial, mental background or base or whatever you might want to call it. Now, Bohm himself, this is the final remark. Bohm wrote, active information is similar in certain ways to the activity of information in our ordinary subjective experience. So there's where I draw that inspiration from. So thank you.